Hello, and welcome to another Let's Study video on Programming Principles and Practice using C++, 3rd edition by Bjarne Straustrup. We have completed Chapter 0, and now we have moved on to Part 1, the basics. We are moving on after completing the self-given exercises that I gave myself. These being, I got the GCC compiler with C++ 23 support installed onto my Windows computer as well as a Linux computer. My laptop. Here we can see it work. Where GCC -- version, enter. I have GCC 15.2.0 installed on my Windows machine. So that task was completed. Second task I gave myself was Visual Studio 2022 range checking enforcement. We got that solved. And finally, we wanted to get the PPP_support module from the www.straustrup.com website, and we also got that done. So now, here we are at Part 1, the basics. Part 1 presents the fundamental concepts and techniques of programming together with the C++ language and library facilities needed to get started writing code. This includes the type system, arithmetic operations, control structures, error handling, and the design, implementation, and use of functions and user-defined types. In Part 1, we have Chapter 1, Hello World, Chapter 2, Objects, Types, and Values, Chapter 3, Computation, Chapter 4, Errors, Chapter 5, Writing a Program, Chapter 6, Completing a Program, Chapter 7, Technicalities, Functions, etc., and finally Chapter 8, Technicalities, Classes, etc. Chapter 1, Hello World. Programming is Learned by Writing Programs by Brian Carnigan. Here, we present the simplest C++ program that actually does anything. The purpose of writing this program is to let you try your programming environment, give you a first feel of how you can get a computer to do things for you. Thus, we present the notion of a program, the idea of translating a program from human-readable form to machine instructions using a compiler, and finally executing those machine instructions. Chapter 1, Section 1, Programs. To get a computer to do something, you or someone else have to tell it exactly, in excruciating detail, what to do. Such a description of what to do is called a program, and programming is the activity of writing and testing such programs. In a sense, we have all programmed before. After all, we have given descriptions of tasks to be done, such as how to drive to the nearest cinema, how to find the upstairs bathroom, and how to heat a meal in the microwave. The difference between such descriptions and programs is one of a degree of precision. Humans tend to compensate for poor instructions by using common sense, but computers don't. For example, turn right in the corridor up the stairs, it'll be on your left is probably a fine description of how to get to the upstairs bathroom. However, when you look at those simple instructions, you'll find the grammar sloppy and the instructions incomplete. A human easily compensates. For example, assume that you are sitting at the table and you ask for directions to the bathroom. You don't need to be told to get up from your chair or to get to the corridor, somehow walk around and not across or under the table, not to step on the cat, etc. You'll not have to be told not to bring your knife and fork or remember to switch on the light so that you can see the stairs. Opening the door to the bathroom before entering is probably also something you don't have to be told. In contrast, computers are really dumb. They have to have everything described precisely and in detail. Consider again, turn right in the corridor up the stairs, it'll be on your left. Where is the corridor? What's a corridor? What is turn right? What stairs? How do I go upstairs? 1 step at a time? 2 steps? Slide up the banister? What is on my left? When will it be on my left? To be able to describe things precisely for a computer, we need a precisely defined language with a specific grammar. English is far too loosely structured for that, and a well-defined vocabulary for the kinds of actions we want to perform. Such a language is called a programming language, and C++ is a programming language designed for a wide selection of programming tasks. When a computer can perform a complex task given simple instructions, it is because someone has taught it to do so by providing a program. If you want greater philosophical detail about computers, programs, and programming, see PPP 2, Chapter 1, and PPP 2, Chapter 22. Here, we start with a very simple program and the tools and techniques you need to get it to run. I may read these PPP 2 Chapter 1 and PPP 2 Chapter 22. I read partial completion of Chapter 1, which was a good read, and partial of Chapter 22, which looks to be a good read. Chapter 1, Section 2, the classic first program. Here is a version of the classical first program. It writes, "Hello World," on your screen. Now, I wish I had a better way of showing this. I wish I could just zoom in the camera like a document scanner or document camera. I don't really have one. Something to get. But I'll still describe the program regardless. We have our first line, 2 words, import an std, followed by a colon, a semicolon. And then we have int main, followed by an empty set of parentheses, a left bracket, and we have std : cout, cout, with left angle bracket together, And we have the text hello, comma, space, world, exclamation mark. And we have this /n. And all of that is contained within double quotes. And we have a semicolon at the end of that line. Finally, we have return and 0 followed by a semicolon. Think of this text as a set of instructions that we give to the computer to execute, much as we would give a recipe to a cook to follow, or as a list of assembly instructions for us to follow to get a new toy working. Let's discuss what each line of this program does, starting with the line std : cout, double left angle bracket, hello world, /n within quotation marks, followed by a semicolon, with a comment line, output, hello world. The core concepts, alert marker, that's the line that actually produces the output. It prints the characters hello world, followed by a new line. That is, after writing hello world, the cursor will be placed at the start of the next line. A cursor is a little blinking character or a line showing where you can type the next character. In C++, the string literals are delimited by double quotes. That is, hello world is a string of characters, with the /n is a special character indicating a new line. The name cout refers to a standard output stream. Characters put into cout using the operator double left angle bracket will appear on the screen. The name cout is pronounced cout and is an abbreviation of character output stream. You'll find abbreviations rather common in programming. Naturally, an abbreviation can be a bit of a nuisance the first time you see it and have to remember it. But once you start using abbreviations repeatedly, they become second nature, and they are essential for keeping program text short and manageable. The std : and std : cout says that the cout is to be found in the standard library that we have made accessible with import std : the end of that line, double / output hello world. Is it backslash? Hold on. Yes, /. Slanted to the right. Up and to the right. The double / output hello world is a comment. Anything written after the token double /, that's the / character twice on a line, is a comment. Comments are ignored by the compiler and written for the benefit of the programmers who read the code. Here, we used the comment to tell you what the beginning of that line actually did. Comments are written to describe what the program is intended to do and in general to provide information useful for humans that can't be directly expressed in code. The person most likely to benefit from the comments in your code is you. When you come back to that code next week or next year and have forgotten exactly why you wrote that code the way you did, so document your programs well. In Chapter 4, Section 7.7.1 and Chapter 6.6.4, we'll discuss what makes good comments. And we have a core concept alert marker here for this next paragraph. A program is written for two audiences. Naturally, we write code for computers to execute. However, we spend long hours reading and modifying the code. Thus, programmers are another audience for programs. So, writing code is also a form of human-to-human communication. In fact, it makes sense to consider the human readers of our code our primary audience. If we, don't find the code reasonably easy to understand, the code is unlikely to ever become correct. So, please don't forget, code is for reading. Do all you can to make it readable. The first line of your program is a typical comment. It simply tells the human reader what the program is supposed to do. In this example, we have the double forward slash denoting a comment, this comment being, this program outputs the message hello world to the monitor. Such comments are useful because the code itself says what the program does, not what we meant it to do. Also, we can usually explain roughly what a program should do to a human much more concisely than we can express it in detail in code to a computer. Often, such a comment is the first part of the program we write. If nothing else, it reminds us what we are trying to do. I have been in that circumstance where I've forgotten what was the point of what I was trying to make. What exercise I was trying to complete, what thing I was trying to do, completely. Now, I haven't had the situation where my own comment has saved me from that, but I have been in that state of confusion. The next line, import std, semicolon, is a module import statement. It instructs the computer to make available, to import, facilities from a module called std. This is a standard module, making all facilities from the C++ standard library available. We will explain its contents as we go along. For this program, the importance of std is that we make the standard C++ stream I/O facilities available. Here, we just use the standard output stream, cout, and its output operator, double left angle bracket. How does a computer know where to start executing a program? It looks for a function called main and starts executing the instructions it finds there. Here is the function main of our Hello World program. Now, I know you can't read that, or most likely won't be able to read that. So what I'm going to do is I'm going to open up Visual Studio, and I will write this code from the book into an example. I'll explain more about using Visual Studio in the future. But for here, let me just get some text on screen. So I'll go back to the program, the classic first program, and write it out from the book. So this program outputs message hello world to the monitor. Import std. We have int main with a body in brackets. We have std : cout two left angle brackets, followed by hello, comma, world, exclamation mark with the forward backward /n, and we return 0 here. And you may notice that we have some errors. That is because we haven't set up the program to do what I've learned before, which is we need to go into project settings. We do that by selecting the project in the top right. We hit properties. It brings up our properties screen. We want to go to C/C++. This grouping of settings or project properties won't be available until you import you add your first CPP file or a header file. And if we go down to language, we can see that we want to change the C++ language standard to this drop down, and we want to choose the preview features from the latest C++ working draft. We want to go down to build ISO C++ 23 standard library modules. We want to select that to be yes. And then there's one more thing I need to do. I think if we go to general, we want to get scan sources for modular dependencies. You want to swap that to yes. We apply these changes, hit OK, and now we notice that all of our errors are gone. And if we quickly test this program, taking a little bit to compile first time, the standard library, we see our function from the book works as prescribed. Okay. Now going back to the book, I will increase me as big as I can without messing up the program. Just follow along a little bit better. Okay. So we have a core concept paragraph. Every C++ program must have a function called main. Now, I don't think that's actually technically true if you consider a dynamic link library of program, which I don't think it does, so I believe that statement remains true. To tell it where to start executing. A function is basically a named sequence of instructions for the computer to execute in the order in which they are written. So, top down. We have 4 different bullets. The first bullet being a return type, here, int, shown here. Meaning integer, which specifies what kind of result, if any, the function will return to whoever asked for it to be executed. The word int is a reserved word in C++, a keyword. So int cannot be used as the name of anything else. Now, I will start writing this sort of pseudo function, because it's going into detail what makes a function immediately without going into saying that. No, it's saying function. It's using the right terminology. So we have return type. Let's put this all in a block style comment. Using the slash asterisk to get that started. And then a asterisk backslash. Oh no, asterisk slash. So a function has a return type, followed by space, well, followed by white space, I believe. The name, then a parameter list, which is in parentheses, enclosed in parentheses, we'll see in chapter 7, section 2, and section 4. Here, double parentheses in this example. I will preemptively put here arguments. If any. And then finally we have the function body, which enclosed in a set of curly braces, which lists the actions called statements that the function is to perform. So then, body. Trying to have how to figure this out. I'm trying to show more general than what is, and oh no, I've already blocked it. Okay, just moving on straight up the book instead of trying to make my own content as I read. All right. It follows that the minimally C++ program is simply int main with an empty parenthesis set and an empty function body. So it takes in no inputs, does nothing, and returns 0. That's not much of use, though, because it doesn't do anything. The main function of our hello world program has two statements in its body. The std : cout, double left angle bracket with hello world, exclamation mark, slash n, backslash n, in quotation marks, terminated with a semicolon, outputs hello world, and we have return 0. First, I'll write hello world to the screen, and then it will return a value 0 to whoever called it. Since main is called by the system, we won't use that return value. However, on some systems, notably Unix or Linux, it can be used to check whether the program succeeded. A 0 returned by main indicates that the program terminated successfully. A part of a C++ program that specifies an action is called a statement. So we have here on line 7, this is considered a statement, as well as return 0 is a statement. And I imagine line 3 is also considered a statement. Specifies an action. Chapter 1, Section 3, Compilation. C++ is a compiled language. That means that to get a program to run, you must first translate it from the human-readable form to something a machine can understand. That translation is done by a program called the compiler. What you read and write is called source code or program text. And what the computer executes is called object code or machine code. Typically, C++ source code files are given the suffix .cpp, for example, hello world.cpp, and the object code files are given the suffix .obj on Windows or .o in Linux. The plain word code is therefore ambiguous and can cause confusion. Use it with care, only when it is obvious what's meant by it. Unless otherwise specified, we use code to mean source code, or even the source code except the comments, because comments really are there just for humans, and are not seen by the compiler generating object code. I don't think that fits completely nowadays, since we have AI co-pilots, AI code writers that read source code. I imagine that they're reading the comments as well. It would be a little bit short-sighted if they're not using the comment information as well to try to accomplish whatever task they're given. So we have a graphic here that shows box of C++ source code with an arrow going into an ellipse container labeled compiler with a arrow coming out of that to another box called object code. So we have the process of C++ source code coming into the compiler and then getting outputted by the compiler as object code. The compiler reads your source code and tries to make sense of what you wrote. It looks to see if your program is grammatically correct, if every word has a defined meaning, and if there is anything obviously wrong that can be detected without trying to actually execute the program. You'll find that compilers are rather picky about syntax, leaving out any detail of our program, such as importing a module file, a semicolon, or a curly brace, will cause errors. Similarly, the compiler has absolutely zero tolerance for spelling mistakes. Let us illustrate this with a series of examples, each of which has a single small error. Each error is an example of a kind of mistake we often make. So, we have our first example, which looks very similar to our program up on screen, except that it looks like we're missing the import std. We have int main, we have std qout, we have the double left angle bracket operator, the insertion operator, as you might call it, and everything else is the same. So we have here the text describing the problem. We didn't provide the compiler with anything to explain what std qout was. So the compiler complains. To correct that, let's add the import. Now we have the second version of our Hello World program, which we have now included the import std, and we have int main, and we have cout, left angle bracket, hello world, \n, and return 0. But if you look closely, we're missing the std double colons. The compiler again complains. We've made the standard library available, but forgot to tell the compiler to look in std for cout. The compiler also objects to this. So now we have our third iteration of the broken versions of our Hello World program. We have import std, we have int main, we have std : cout with double left angle bracket, but there is a difference on that line. The hello world message is not enclosed with the double quotes. We didn't terminate the string with a double quote. The compiler also objects to this. And then here we have our fourth iteration of a mistakenly programmed Hello World program. We have essentially the same program, except for the int in int main is replaced by the word integer. The abbreviation int is used in C++ rather than the word integer. The compiler doesn't like this. And then here we have the fifth program, which looks good on the import std, looks good on int main, looks almost good on the std qout, but instead of a double angle bracket, we have a single angle bracket, which is a completely different operator. We used the less than operator rather than the double left angle bracket. Also, now we have the word for it, the output operator. Then we have our sixth problem program, which we have import std, looks good, int main, looks good. And we have std : cout, looks good. But our message, instead of being enclosed by double quotation marks, we have single quotation marks. We used single quotes rather than double quotes to delimit the string. Finally, the compiler gives us an error for this, which is, I believe, our 1, 2, 3, 4, seventh problem program. We have import std, looks good, int main, looks good, std double cout, looks good. We have our output operator that looks good. And we have our hello world delimited string, which does look good, except for that line has a problem. We are missing the semicolon at the end of that, terminating this statement. We forgot to terminate the output statement with a semicolon. Note that many C++ statements are terminated by a semicolon. The compiler needs those semicolons to know where one statement ends and the next begins. There is no really short, fully correct, and non-technical way of summarizing where semicolons are needed. For now, just copy our pattern of use, which can be summarized as put a semicolon after every expression that doesn't end with a right curly brace. Finally, let's try something that surprisingly works. We have import std, we have int main, we have std qout, with our output operator, the hello world text in double quotes, and terminated by the semicolon. For historical reasons, we can leave out the return statement in main, and only in main. And it is as if we had written return 0, and the end of main's body to indicate successful completion. So then, why do we spend 2 pages of good space and minutes of your precious time showing you examples of trivial errors in a trivial program? To make the point that you, like all programmers, will spend a lot of time looking for errors in program source text. Most of the time, we look at text with errors in it. After all, if we are convinced that some code was correct, we'd be looking at some other code or taking the time off. It came as a major surprise to the brilliant early computer pioneers that they were making mistakes and had to devote a major portion of their time to finding them. It is still a surprise to most newcomers to programming. When you program, you'll get quite annoyed with the compiler at times. We have this advice alert marker for this paragraph I just began reading without alerting. When you program, you'll get quite annoyed with the compiler at times. Sometimes it appears to complain about unimportant details, such as a missing semicolon, or about things you consider obviously right. However, the compiler is usually right. When it gives an error message and refuses to produce object code from your source code, there is something not quite right with your program. That is, the meaning of what you wrote isn't precisely defined by the C++ standard. Then we have a warning. Is it warning or is it danger? Warning. Okay, so we have a warning marker, not an alert marker. Excuse me. Hold on. Is it an alert marker? I believe they're all alert markers. Yes, they're all considered alert markers. This one is considered with the double red X to be a warning marker. Okay. The compiler has no common sense. It isn't human and is very picky about details. Since it has no common sense, you wouldn't like it to try to guess what you meant by something that looked okay, but didn't conform to the definition of C++. Increase the view just in case you can read or want to try to read. Apologies, don't have a document camera. If it did, and its guess was different from yours, you could end up spending a lot of time trying to figure out why the program didn't do what you thought you had told it to do. When all is said and done, the compiler saves us from a lot of self-inflicted problems. It saves us from many more problems than it causes. So please remember, the compiler is your friend. Possibly, the compiler is the best friend you have when you program. Okay, we have chapter 1, section 4, linking, starting off with an alert marker for a core concept. A program usually consists of several separate parts, often developed by different people. For example, the Hello World program consists of the part we wrote plus parts of the C++ standard library. These separate parts, sometimes called modules or translation units, must be compiled, and the resulting object code files must be linked together to form an executable program. The program that links such parts together is, unsurprisingly, called a linker. So we have a graphic here with two source files following their path from their file contents to the compiler, outputting object code, and then they merge as inputs into the linker, with finally the output from the linker being an executable file. The output from a linker is called an executable file. I've heard the word executable, but it is executable. I like executable file. And on Windows, its name is often given the suffix .exe. Please note that object code and executables are not portable among systems. For example, when you compile for a Windows machine, you get object code for Windows that will not run on a Linux machine. A library is simply some code, usually written by others, that we access using declarations found in an imported module. For example, I wrote some there. Keep using my pencil as a pointer. End up writing on my book unintentionally. Okay, we have a graphic here with hello world.cpp going through the compiler, producing an object file, say object file 1, and then below it we have the module std going through its compiler and producing its own object file, in this case object file 2. We have now both object file 1 and object file 2 joining together as inputs into the linker, which output finally the executable file. A declaration is a program statement specifying how a piece of code can be used. We will examine declarations in detail later in Chapter 3, Section 5.2, and Chapter 7, Section 2, or Chapter 7.2. Errors found by the compiler are called compile time errors. Errors found by the linker are called link time errors. And errors not found until the program is run are called runtime errors or logic errors. Generally, compile time errors are easier to understand and fix than link time errors, and link time errors are often easier to find and fix than runtime errors. In Chapter 4, we discuss errors and the ways of handling them in greater detail. Grab a glass of water, and I'm also going to try to pause the recording. Hopefully it doesn't break and lose all of my progress. And it looks like we're back and the pausing worked. Chapter 1, Section 5, Programming Environments. To program, we use a programming language. We also use a compiler to translate our source code into object code, and a linker to link our object code into an executable program. In addition, we use some program to enter our source code text into the compiler to edit it. These are just the first and most crucial tools that constitute our programmer's tool chest, or program development environment. If you work from a command line window, as many professional programmers do, you will have to issue the compile and link commands yourself. See Chapter 0.3.1. Now, that is this quick example, I believe. Down here on portability, we can see this line that we use down here to compile our, well, this isn't our Hello World program, but this is a small program that contains two source text files, or .cpp files, and produces a single executable output, my program. If instead you use an IDE, or Interactive Development Environment, or Integrated Development Environment, as many professional programmers also do, a simple click on the correct button will do the job. So that's what we have here. We have Visual Studio Code 2022 Community Edition, and we have sort of our build is just this button up here, Local Windows Debugger, where we have, of course, the build solution up here. And then we have GCC, which is our command line version right here. So we have both to work with and experiment with. IDEs usually include an editor with helpful features like color coding to help distinguish between comments, keywords, and other parts of your program source code, plus other facilities to help you debug your code, compile it, and run it. Debugging is the activity of finding errors in a program and removing them. You'll hear a lot about that along the way. An error in a program is often called a bug, hence the term debugging. The reason for calling an error a bug is that in a very early system, a program failed because an insect had found its way into the computer. See PPP 2, chapter 22.2.2.2. I believe it was a moth, and it got stuck between a relay. Working with this book, you can use any system that provides an up-to-date, standards-conforming implementation of C++. Most of what we say will be true for all implementations of C++, and the code will run everywhere. In our work, we use several different implementations. And now we have a drill section, or we have now entered the drill section of this chapter, Chapter 1, Hello World. Drill. So far, we have talked about programming, code, and tools, such as compilers. Now, you have to get a program to run. This is a crucial point in this book and an important step in learning to program. This is where you start to develop practical skills and good programming habits. The exercises for this chapter are focused on getting you acquainted with your software development environment. Once you get the Hello World program to run, you will have passed the first major milestone as a programmer. The purpose of a drill is to establish or reinforce your practical programming skills and give you experience with programming environment tools. Typically, a drill is a sequence of modifications to a single program, growing it from something completely trivial to something that might be a useful part of a real program. A traditional set of exercises is designed to test your initiative, cleverness, and inventiveness. In contrast, a drill requires little invention from you. Typically, sequencing is crucial, and each individual step should be easy or even trivial. Please don't try to be clever and skip steps. On average, that will slow you down or even confuse you. You might think you understand everything you read and everything your mentor or instructor told you, but repetition and practice are necessary to develop programming skills. In this regard, programming is like athletics, music, dance, or any skill-based craft. Imagine people trying to compete in any of those fields without regular practice. You know how well they would perform. Constant practice for professionals that means lifelong constant practice is the only way to develop and maintain a high-level practical skill. Now we have an alert marker of a warning type. So, never skip the drills. No matter how tempted you are, they are essential to the learning process. Just start with the first step and proceed, testing each step as you go to make sure you are doing it right. And then we have an advice marker. Don't be alarmed if you don't understand every detail of the syntax you are using. And don't be afraid to ask for help from instructors or friends, or me. Put your questions in the comments, and I will get back to you. Keep going. Do all of the drills and many of the exercises, and all will become clear in due time. So, here is your first drill. All right, let's get this. Yeah, my bones. All right, drill. Step 1. Figure out how to compile and run a program on your machine. This may be a good time to get a bit of help from someone who has done that before. Well, I am that someone who has done it before. Let's do it again. So I'm going to shrink me down pretty small. And let's do it again. So I close this out. And we're going to close this out. All right, so we now have the blank screen. So, I got Visual Studio. From this site, https visualstudio.microsoft.com, and I downloaded the Community 2022 edition. And I believe that the installation you would get comes with the Visual Studio installer program, which will show you here. We have the Visual Studio Community 2022 edition installed. Ooh, looks like we have some updates. I'll run those real quick. Oh no. Oh, okay, we're back to recording. Sorry about that. I hit the mic with the light. Okay. While that is downloading, I'll show you how I got GCC working. So I'm going to find it in the history. Sorry. Pause it here. Let that continue, and I will come back with an answer to the GCC. Okay, so that didn't take too long. I just had to go back in the history, browser history, to find where I got this from. So this is a pre-compiled build. So it's a it has been built by someone else using their compiler to produce their executable program. I guess they used a linker as well to build an executable. And this will be for the Windows 64-bit operating system, which is our operating system. So we can download that program, place it onto our computer, and then with that on our computer being built for our computer, it can run. And I had to do one other thing to get this working. So I downloaded it, I extracted the files, I placed them onto my local disk, straight onto my root as the extracted folder, the GCC-15.2.0, which was the latest edition available in this package from SourceForge. And then I needed to edit system. Sorry, let me slow down there. I went down here to the start menu. I typed in edit system, and it comes up edit the system environment variables. I open this up and we go down here. So this is like system properties. And we have the advanced tab. And if we go down here, we have environment variables. We select this. And then down here, we have the path variable for this user. So this is for me. And since I only have one user of this computer, which is just me, editing this is practically, it's a good solution for everything. We can edit this path such that the path variable also includes this new path here, which is this, the GCC folder, but one folder in going to the bin folder. So we go down here, GCC, bin. So we give our program, not our program, we give the Windows operating system the variable path, an additional line, which directs us to here. So when the Windows command prompt and PowerShell execute or attempt to execute a function, it will also look here for the functions that we just called. In this case, we have C++.exe, which is our C++ executable. We have G++.exe, which is supposed to be, and well, it looks like the byte sizes are exactly the same. It's supposed to be the same. G++ is the same as C++. And not only did we get the G++ compiler, we also got the GCC compiler, which compiles C code. And it looks like we have a whole bunch of other programs available as well, such as, I believe one is interesting, is the objdump.exe, so the object file dump program, which we can take our object code that we have built and we can break it apart and view the contents of it so we can see how it built, to see some issues, or just to learn a little bit more about how that build file ended up working. Okay. So that's how I got GCC working. And you can tell if you did it correctly if you open up a command prompt and you're able to type in the GCC, or I should be saying G++, or I'm gonna use C++, and then -- version. And if we enter in that command, we can get the version of our C++ compiler. In this case, 15.2.0 as of this video. Last updated 12 days ago. Not even 2 weeks. All right, now we're still installing packages. Sorry about that. So, with this still installing, we can say, create a new folder here. And we can call this our Hello World GCC. And this is where we'll do a Hello World in, well, actually, let's just call it Hello World. Now, the folder moved itself down here because I have a sort function working. Do I? Okay, we open up Hello World. We have, of course, an empty folder. And now let's create 2 new folders. Let's call this Hello World GCC. Well, let's do one folder for the moment. Let's do GCC since we're still waiting for the Visual Studio to install. So Hello World GCC. And now let's create a new file. Now we can click text document, but if we include the extension in our edit, we can give it the .cpp ending, which is what we want. So we can give this main.cpp, or in this case, we should do hello world.cpp. Press enter, and we get this dialog message. If you change a file name extension, that file may become unusable. Are you sure you still want to change it? So yes, we do want to change it. because we're changing it from a text file to a CPP file, which, although the contents won't change with changing the extension, it will be a little bit more clear to us and actually even to the operating system that the type of the file that we're working with is a C++ source file. Okay, and then we can edit this source file, and oh, look at this. It opened up Notepad of all things. Well, if you think about it, our source files are nothing but text, which is written in a language, C++ in this example, which can be read by us as well as the computer, but not actually the computer, but the compiler. And so any text editor, really, that can edit a CPP file or a text file working with human readable text characters, well, can be working as our editor. And so here, I'll just use Notepad for this first example. We'll use other editors in the future, mainly Visual Studio 2022, but hey, we're going to try Vim as well. Some people will be very excited about that. So we want to import our std. We want int main. We want our std qout output operator, and then we have our hello, comma, space, world, exclamation mark, backslash, n, terminating that string, literal string, with its double quote, following off with a semicolon to exit the statement or complete the statement. And then we want to return 0, despite the fact that we don't have to. And now, well, that's hello world. That's CPP. Okay. So then, part 2 of our drill. If you use an IDE, integrated development environment, or interactive development environment. I didn't know about interactive. If you use an IDE, set up an empty console C++ project called hello_world. Otherwise, if you plan to use the command line, get a command window. Figure out how to use an editor to type in your code and see chapter 0.3.1, which I believe is the example of, yes, the GNU C++ compiler. In which case we're using the GNU compiler on Windows. Okay, so we want to close this out after saving it. We have our installation, we have our installation of Visual Studio 2022 installed and up to date. We can launch this. And we want to create a new project. We want to create an empty project. Now, the book wants us to set up an empty console C++ project called Hello World. So I'm going to use the empty project here, C++, knowing that it is console. So Windows, all project types, console, empty project. Okay, C++, Windows, console. So this is our project template. And so this is one of the ones that comes installed with Visual Studio. So we select that, we open it. And now the drill asks us to set up an empty console C++ project called hello_world. So hello_world. And let's select the destination to be the folder on our desktop. Hello world. Let's create a new folder. In our hello world folder, we're going to have hello world vs22, which I like to use for the Visual Studio 2022 edition abbreviation. And we're going to select that folder and use that for our dialog screen here. Selecting the location folder for this new project. And we want to keep the solution and project in the same directory. Now, this is something you might not want to do for projects solutions that end up having several projects, but it's not in our best interest at the moment. And then we hit create. And then Visual Studio would generate our project and open it. Now, what do I mean when it generated our project? Well, if we go back to our Hello World folder and go to Hello World vs22, come in, we have now generated a hello_world, our project name folder. And if we enter this folder, we see we have 4 files visible. And if I turn off hidden items, we won't see the .vs. I'll bring it back later. But we have 4 files. Details list, small icons, content. Okay, so we have 4 files that were generated by our Visual Studio 2022 Community Edition when we generated this C++ empty console project. We have our project name.sln. This is our Visual Studio solution file. We have our hello_world, our project name.vcxproj, so our VCX project. This is our VC++ project file. And then we have our hello world, our project name.vcxprog.filters. So we have our VCC++ project filters file. And finally, we have our hello world.vcxproj.user, or our per user project options file. And so I'll briefly talk about what these are in most likely a very incorrect manner. So our solution file will sort of define practically everything about our project, what files and what things are working on. And then our VCC project file will determine sort of our project specific properties. And so we have sort of 2 layers. If you look here in our solution view on the top right, we have our solution, which has its own properties. And then below that, we have our project properties. So a single solution can have several projects. And though that solution itself can have overarching properties over top of our projects, which our projects have their own properties, such as the ones that we edited before. Notice we don't have our C/C++ options here because we don't have any C or C++ files available, placed within this project yet. So if we do that, where we complete step 3 of our drill, type in hello_world.cpp exactly as specified below. Save it in your practice directory folder and include it in your Hello World project. Okay, so that's where we are right now. So if we right click on our source files and hit add new item, we have this dialog option, and we want to name this CPP file as described hello_world.cpp, and we hit add, and here we are. So then we can hit hashtag, we can start typing in the program as written in the book. Hashtag, nope, we don't want to use hashtag. We want to use the highest level available feature first, when applicable. In this case, totally applicable. So we're going to use import std semicolon our int main with no variables, empty parentheses, I should say. We have std : cout, and then we have our output operator and our string hello, comma space world with our backslash, well, exclamation mark, backslash n, and then we terminate this statement with a semicolon, and then we return our final statement, we return 0. Now we did forget some of the things that was already talked about in the book. Our first comment, this program, sort of what the program does. This program prints hello to the screen. Okay. Give a comment here. Prints hello world to the screen. Okay. So if you notice, we have these red squiggly lines here in our IDE of Visual Studio. These squiggly lines are showing us errors, and these errors are caused by the fact that we're using the wrong project settings. And so we will set the project settings to reflect the newer features of the C++ language. So this is at least C++ 20 versions of techniques that we're working on with C++ 20, introducing imports of modules. So if we go to our project file up here, we right click and we hit properties. We will now see that we have the C/C++ configuration property section. And if we go down to language, we can change our C++ language standard from the ISO C++ 14 standard, which does not include modules. We want to drop that down arrow. And now you would think you would be able to use the ISO C++ 20 standard, but we could try it right now, but I don't think it works for this example. Never mind. I believe it does work, but we have to go down here and we choose this option to build the ISO C++ 23 standard library modules. So we hit yes there. Then if we do have to go back up, and not for this example, but the scan sources for module dependencies, we want to turn that on. It should be on when you're working with, ooh, this is cool. Translate includes the imports. I'd love for that to work. I have to experiment with that later. Oh, I didn't see that. Okay, so we want to hit that yes, the scan sources for module dependencies and the general C, C++ configuration properties of our Hello World project. We do want to hit yes on that. We do want to go to language, change our C++ language standard to ISO C++20 standard, as well as enabling our build ISO C++23 standard library modules. We hit apply, hit OK. Now, we do get a message down here from IntelliSense. IntelliSense is sort of the background process of Visual Studio, which is adding all this extra information to our code visual output. So when we're looking around and we see these squiggly lines, these highlights, and these messages, that's IntelliSense. Okay, so if we check here, could not find the module file for module std. Well, I don't think we built it yet since we've created a new project. So if we go up here to build solution, we can hit build solution. And we can see down here, we have an output message of our build. And it looks like, well, it failed. Now, why did it fail? So we scanned sources for module dependencies. We found, well, we have our hello world.cpp file, and we immediately start compiling, and then we immediately fail. And why? Because we can't find the module called std. Well, it's because it's not compiled or it's not visible to the language C++20 language standard in the project settings. So if we go back to our project settings and go back to our C++ language standard and raise it up to our, let's try the preview, the ISO C++23. So we could not find the module, std. Let's try to build again. And fail again. Okay. Let's see how far we got. Looks like we have a whole bunch more error messages. Okay. So we started the build, but we have a command line warning D9002, ignoring unknown option /std:/C++ 23 preview. So it looks like our option to use the C++23 preview edition just got broken or ignored in this compilation, or like this compile. Although, well, it's saying it ignores that option. It ignores it here and ignores it here 3 times. Now, it did find the std.ixx, or the module source file for the std file, the std library, and we also found the std.compat.ixx file, which is another module file, with the, since it's named with the prefix .ixx. Here we go. This confuses me. So we have this. We have error C1189 #error. The standard library modules are available only with C++20 or later. What? We're using C++ language standard 23. Last time I checked, 23 is bigger than 20. Okay, so it doesn't work, or the C++20 preview option isn't working with the Visual Studio Builder compiler, whatever the program is called, or what's working in the background right here. So I think this is obviously the compiler, but it also does the linking together, so I'm not quite sure. I guess builder? Is there a word for the combination of a compiler and a linker? I'm not sure. Okay, but I do know the solution to this, because practiced it before making this video. So if we go to Hello World, right click, properties, go back to our language, do a C++ language standard, do that drop down arrow, and we want to go all the way for the beans to the features from the latest C++ working draft. So std C++ latest option. We hit apply on this, and boom, all of our problems go away. Does this mean our program will work? Let's cross our fingers and hit build. Okay, so we're scanning sources for our module dependencies. We have the hello world source file. We have stdcompat.ixx module file. We have the std module file. All three of these are compiling together at once. And now, notably, std.ixx and the stdcompat.ixx, if their source files don't change, their module files that are compiled into object code don't have to ever be recompiled. Unlike the hashtag includes, if you have learned that in the past. So, well, we have one build succeed. So let's try to run it. With the option at the top, there's a little green arrow, so it is a play button. We hit local Windows debugger, and we hit play, and we wait. Ta-da! Hello world! We're a programmer now. Or at least, once you get the Hello World program to run, you will have passed the first major milestone as a programmer. Getting your computer set up, learning how to do this, learning how to type in and edit these files, how to build, run, and execute those files all in one place, or just being able to do that in general. Aha! Perfect. We've done it. Okay. Yay! All right. So let's go down, see if we skipped ahead at any point. So step 3, type in hello world.cpp exactly as specified below. Now we didn't do that, so let's go back. Exactly as specified. Start by executing the function main. Okay. So then, what if you don't have an up-to-date C++ implementation that supports module std? Then use a less elegant and less effective technique that has worked since the early days of C. Hashtag include a header file as explained in chapter 7.7.2, in which case we have, instead of import std, we have 2 lines, not 2 lines, we have 1 line, hashtag include iostream. So we might have to use that with the GCC. So let's try the GCC. So we've done our IDE, a very high level building environment with the Visual Studio. Let's try GCC, our command line, very bare bones system. Close this out. Go to a Hello World GCC folder, and we have our Hello World program here. And in this case, I will actually open a command window here. In order to have that option, the shift right click, open a command window there, you have to edit the registry files of your Windows installation. It is very much not difficult. Google it. It'll be a quick, easy thing to do. Very, very useful, especially if you're going to be programming on this computer. Okay, so we have our terminal open. So now let's go into, well, let's make sure our GCC is still here. C++ -- version Oh, look, it didn't magically uninstall itself, or at least it's still here. Because, well, honestly, could you tell it's there or not from just opening the command prompt? No. When you open up Visual Studio, you know Visual Studio is still there. Okay. So then, we're actually going to use the program called Vim. So we're going to type in VIM C++. Now, installing Vim on your computer, not very difficult as well. Sort of very similar to our our GNU compiler, our GCC compiler instructions I gave a little earlier. But I'll let you go out and find that instructions yourself. You might want to install it in a different location or with a different version of Vim or Vi or whatever editor you want to work with. I'll use Vim in this case. So we want to use Vim, and we want to do the main, not main, we want the hello world file. So hello world.cpp. So we do Vim and then the file name, it will open that file, and aha, here we are. We have the file. Oop, turn my light on by accident with my pinky. So we have the import std, but look, we're missing our initial comment. So if we see down here with Vim, you don't have this, well, it's missing. We are not in insert mode. Insert mode is sort of edit mode. So we're now able to edit this program. Now, how did I enter that? I just hit I on the keyboard, and now I'm in insert mode. And so when I type on the keyboard, we get results, edits to our file up in the editor window above. So in this case, we want to shift down the line, and then we can write in this program. Outputs hello world to the screen. Okay. There's a lot of helpful stuff that Vim will do for you, which was not so helpful, giving us comment lines when I hit enter there. So there's a lot of quick things that help with this. Okay, so we edited the program, and now what we can do is we can exit the insert mode with escape on the keyboard. And so now we're free to move around without the fear of editing our file on accident. So it's sort of like a read-only mode at the moment. See visual. But now we want to enter a command in, because now we've edited this file, but we have not saved it. So if we shift colon, or just colon, we see this little terminal, this little cursor down here, and we can type in our functions or our commands. So in this case, we want to use the write command, which will write to the file the changes we've made. So save the changes. Now we can also use the abbreviation :W to write. Okay. And now after we have written or saved our file and edited it, and we want to use it now, let's exit Vim. And how to exit Vim, you just do quit or Q. And now we'll exit us out of Vim. So here we are, now back at our command prompt, and well, we never really left our command prompt. We just opened up Vim as an executable, and we had our terminal window being edited live by the Vim program. Okay. So now we want to compile. If we list our files using the dir function of the Windows command prompt, it would be ls in a Linux operating system. We can see that we have 3 files. So we have the .helloworld.cpp.un with a little tilde key at the end of it. And it looks like we have another helloworld.cpp with a tilde after it. Now these files, or at least I'm confused about why we have 2 of them, but I do know the first one, the .un tilde key. This is an undo file. And so those changes that we've done to hello world.cpp, the undo ability to change those changes that we did to revert them is stored in a separate file from Vim. So Vim made that file. Now we can just ignore it for now, or we can disable it if we want to keep our files tidy and have only our source files in whatever current state they're in and having no way of going back, which is okay. Sort of like what Visual Studio is like. Once you save your project, close it, you can't really come back to it and Control-Z your way back to some save point. With Vim, well, seems like you can. I wonder how far back those changes go. I don't know, but it could be far. Okay. So we have our Hello World file here available where we're at in our current directory. So then we can type in the commands C++ or G++. I will use C++. We want to point it to our file, but I will say this before we do. So we can do it, we can type it in, C++, our file, which will be hello world.cpp. Autocomplete screwed me there. So C++ hello world _.cpp. Now, this would compile an object code. So we'll get our hello world.cpp in, and we'll get our hello world.o or our hello world.obj file out. So this command right here, unedited, is just the compiler, not the linker. But if we wanted to link, we'll do the -o and then give it a name to name our executable. In this case, hello world. Now, if I hit enter, I know this, it won't work. It's like, oh, what's this? Import. Import's not known. Why is import not known? You guessed it. Our compiler is compiling with an older version of C++. We want the newer version of C++, practically the latest version. So now, how do we get it to do that? We need to specify it precisely. So we press up on the keyboard to bring up our previous commands, just for a little quick typing. And now we can go back to our previous command that we typed in. And we can see in right here, C++20 import only available with -f modules. So, well, let's use that. Let's follow that advice. Remember, always read the errors. Read the documentation. It will help you so much. Just read. Take the moment to read. The people that wrote these comments specifically made that these would show up when this problem would come into existence. And so if you're getting a message, it means that someone took the time to write that message and the logic to make that message appear when it does. Therefore, it's usually a good idea to read that error message. Okay. So let's use that F modules. So we have C++ -f modules. Okay, now is this all we need to do? Let's try. Let's press enter. Woo-oo. Failed to read the compiled module. No such file or directory. That compiled module is gcm.cache, std.gcm. Imports must be built before imported. Aha! So that's the error we have. The standard library module file wasn't built before we tried to use it. Okay, so now we need to get that working as well. So I forget how I got that working. I will pause the recording, figure out what command I needed to do to get that to compile along with our Hello World program. Okay, coming back. As you can see here, I don't think I had much success getting GCC or G++, the GNU compiler version 15 working in my Windows environment. I believe that I got it working on my Linux computer, which is actually, I believe, the 14th version. I'm seeing a lot of mixed information online about module support. Quite frankly, I'm very surprised about the lack of instantaneous support for modules. I can see why. They're very different than how compilation using the preprocessor has been, but bit disappointing. But we got to work in Visual Studio, and since that's what we're primarily going to be working with in the future, since, well, I've already climbed that learning curve to using it, and I believe, well, using a text editor and the command line arguments to build entire large projects is a little difficult, especially for the novice. So let's continue with Visual Studio 2022 Community Edition. I apologize. I wish I got this working, but I won't be able to get it done or get it working in this video, or at least just tonight. We can pick it back up tomorrow, see if we can get it working. Yeah. But let's continue with the drill, finish this out, and we can hit the review, which I believe I'm going to save for another day. Let's finish the drill, though. I believe we've done everything, but let's make sure we've done everything. So, step 4, compile and run the Hello World program. An IDE will have to compile and run button. Even something as simple as Hello World very rarely compiles and runs in a first attempt to use a new programming language or new programming environment. Find the problem and fix it. This is a point where asking for help from a more experienced person is sensible, but be sure to understand what you were shown so that you can do it all by yourself before proceeding further. Now, let's go back, clear this. And so we still have our hello world.cpp file here. And if we edit it, we can, instead of using import, we can use the archaic hashtag include iostream. If I can spell include right. Remember, we go back here. Where was the line? Here we are. Similarly, the compiler has absolutely zero tolerance for spelling mistakes. A fun part of programming. Okay, so then. So we've modified our program to, instead of using the import std statement, we're going to use the hashtag include preprocessor command to grab from the std library the iostream library function. I forgot what it's called. I don't know what iostream would be called. Well, it's a header file, so it'll be iostream.h, but we can remove the h.h in in this case. Okay, so we want to write this, exit insert mode, and we can do two things at once. This is cool about them. We can do WQ, and so we'll save the file, save and quit, all in one. And then we can do C++, hello world.cpp, give it an object file, destination, or a linker, just hello world. Well, it didn't give us an error message, but with a compile, with a command line argument, that usually means things went well. So if we look in our directory, we have an executable of like 53,000 bytes, hello world.exe. And so we can try to run that program, hello world.exe. We press enter. It broke. The code execution cannot proceed because lib stand C++. The DLL was not found. What? What broke? Why broke? Why roof burning? What did I do wrong? Everything breaks, and everything breaks. Everything breaks all the time. Okay, well, it doesn't work because it's expecting to find a DLL, a dynamic link library, which is gone, or just doesn't exist. Why is this happening? CP, hello world. Instead of linking, we're going to remove that and just compile hello world. That will bring up our, well, it looks like, oh, a.exe, same problem. A.exe, where's our object file? Interesting. Can we object dump a.exe? Object dump. Disassemble. Yikes! That's a lot of code. Okay. Lots of code. Good. All right, cool. If printf, if printf. You see, like, this is like, it looks like it's the contents of IO stream entirely. String copy. No, doesn't look like all the contents of IO stream. All right, let's go all the way up to the top. Oh, we can't even go up any further. Okay. Well, I was hoping to see the links to the libraries it's looking for. Hold on. System source. No, I've done that. Dash S. Whoop. I don't think this is helping. It looks like the exact same thing. That doesn't look any more helpful. Let's clear OBJ. Okay, so I'll leave this here. Command line isn't working. We do have a backup, which is our primary anyways. This is our backup not working. Always good to have two methods of completing something you need to do or want to do. Redundancy is great, but, well, a backup generator or a backup compiler, not working. I'm sure I'm just being dumb, but dumb I am. Okay. So we've compiled and run. We've finished. Step 4. Okay, well, step 5. By now, you probably encountered some errors. Yep. And had to correct them. Well, we tried. Now is the time to get a bit better acquainted with your compiler's error detection and error reporting facilities. Try the 8 programs from chapter 1, section 3 to see how your programming environment reacts. Think of at least 5 more errors you might have made typing in your program and try to see what happens when you try to compile and run those versions. Okay. So let's go back a page. And another page. And another to chapter 1, section 3 on compilation. We have our 1, 2, 3, 4, 5, 6, 7, 8 broken programs. And we're going to see how they look like in both Visual Studio and GCC. Because I know the GCC is still compiling correctly, but it doesn't look like it's linking correctly, which, I don't know. Okay, so let's go back to Visual Studio where things make sense. So if we go back to Hello World, VS22, in the Hello World project folder, and then we open up the Hello World solution, we'll get back to where we were, which is information stored from our files. There's 4 files. Okay. So we have our Hello World program here. I don't know why it opens to this weird shrunk format. I wish I knew how. Please let me know in the comments if you know how to set the dimensions that a program uses when it starts up. Not that that is completely settable, or if I even know that's possible. But having certain windows open up in weird smaller sizes and at weird locations is not helpful, and I'd love to be able to get rid of that. Okay. So then, let's start with the first one. Each error is an example of kind of mistake we often make. The first one is we don't provide the compiler anything to explain what std_qout is. So, well, what explains it? Import std. So if we comment that out and we give it a second, IntelliSense shows us, hey, the namespace std has no member cout, because our import std module has the cout in it, and once we commented it out, it no longer exists. Okay, so if we try to build this, hello train, we'll see that it failed, obviously, and we can see it failed with an error. C2039, cout is not a member of std, and we have our, well, that's all we really need. This is one, the error C2065. We're going to see that a lot, all the time. Cout, it's the undeclared identifier error error code that we get with Visual Studio's build. Okay, so we see that the build fails, and our integrated development environment or interactive development environment tells us before we even build with these little red squiggly lines, and if we hover over it, we get an error description. E0135, which is different than the compile error. Oh, look. We got show potential fixes. Add hashtag include IO stream. Now that would fix it, but that solution is for the old version of C++. We want the new version of C++. So that, considering we're using the newest version, that should either give us two options, add the include IO stream, which it's giving us now, but also the import std or import IO stream module. So that's what we get in our environment. Yeah, that's number one done. Okay, number two. Didn't provide, okay, sorry. The compiler again complains, we made the standard library available, but forgot to tell the compiler to look in std for cout. So that's what this does. This std : tells us to look in the namespace, or in the namespace of the module std for cout. And if we don't provide it that, cout, it's looking for cout in this namespace, this file. And well, we haven't declared what cout is within this file, so it can't identify it. So it's undefined. So we never defined it above here. So it goes down, 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 hits cout, looks in the past, and oh wait, cout was never defined. And so it complains. We get a telesense telling us of the problem. We get an error number, identifier is undefined, and we get the potential fixes. We include the IO stream. Now this is what's interesting, because that actually wouldn't fix it either. Would it? No, it wouldn't work. Cout is undefined, show fixes. Okay, well, it would get us closer. And then the next suggestion would fix it. That is true. All right, but we don't want to do that. Okay, so let's build it, though. Attempt to build it. We know it's going to fail, so let's build. See what messages we get. All right, and what did I say? We get our messages, our very common problem, error C2065, undeclared identifier, cout in this case. Okay, so let's declare it, or at least tell it where it was declared, which is in std. Okay, that does number 2. All right, number 3. All right. The problem was that we left out the double quotation mark terminating this literal string hello world with the new line character. So, look what we got. We got error 000, we get error 8 missing closing quote, and no potential fixes available for auto completion. But hey, it does show us this, and then we got 2 errors. We got missing closing quotes on line 7, and then on line 9 we have the error 65 expecting a semicolon. So it's expecting us to have a semicolon out here. Now, why can't it see this semicolon? It can't see that semicolon because it thinks it's a part of this string. And so it doesn't really see it. It's not really available for it to do its job. So that's what it looks like. And if we try to build, let's see what errors we get. All right. Failed. We got the error C2001, new line in constant. Never seen that error before. And then error C2143, syntax error, missing semicolon before return. And so it really doesn't actually have an error for this one, but it does have an error for the return. So it's expecting this statement to end before it hits return, this keyword return. And well, we never got to it because, well, we never left this string, which gave us this. So if we add our double quotes back, we get the program back to a working order. That's the third broken hello world example. Let's move on to the fourth. The abbreviation int is used with C++ rather than the word integer. So int main works. Integer does not. That's because integer, the word integer, is not defined as an int. We use the definition int to be our name. So integer, and this will probably give us the 2060 compile error. So let's build. Ooh, we got more. Error C4430, missing type specifier. So main is expecting to get a return type here, but this return type, this evaluates to nothing. Integer is assumed because it's missing the type specifier. Now note, C++ does not support the default int. Oh, that's interesting. I didn't know that. Can I do this? Ooh, it doesn't. I know in C it will. Okay. So let's bring that back. Integer. We know it broken. Let's try to build anyways. Go back to these error messages. We get syntax errors before the identifier. So this is just breaking everything right here. Missing a function header. So like this function header line 5 is just broken. Okay. Now, I will say, can we not type def integer? Will that work? If I can spell right. No. Oop. Yeah. Will it work? Heck yeah, it will. This is what I like. This is a language feature. I can define my own types, and those types, keywords, can be used in place of it. Now, it's not like I brought in new functionality. I just renamed a base class type. But heck, that is a feature, and it works. Will it be useful? Who knows? But we can get it to work anyways. That's the cool thing, I guess. Okay. All right. Then we use the less than operator rather than the output operator down here. What does that look like? So there's no less than operator matching these operands. So when we have an operator like this, we have our left-hand side and our right-hand side. These are our left operand, and this is our right operand. And this operand, a less than operation between stdqout and a string literal, is undefined. So there is no operator defined that would do anything of known function here. And without explicitly knowing what to do between these two, it won't work. So if we try to build this, looks like we got a huge error list. Huge. Oh my gosh. Error binary less than operator. No operator found, which takes the left-hand operand of type std basic ostream car stand car traits car. What the heck? Is that what? Hold on. Is that what cout is? Is that what cout truly is? Hold on. Never mind. Trying to do something clever. Okay, well, that's the errors we get. Okay. Then, all right, then we use single quotes instead of double quotes. Alright, what does that look like? Too many characters in character constant. So yeah, these single quotes are used to define a single character, like the letter H, the letter E, L, and as well as the escape character here, the new line character, which actually counts as one character. Yeah, too many. So it won't build. Let's see. Well, the IntelliSense is warning us. Let's see what error we get. Easy one, 2015, too many characters in constant. That's it. Just one compile error, and it just fails to compile past that. It's a busy. All right. Bring it back to normal. And we want to go to forgot to terminate the output string with a semicolon. Okay, so go here and just take the semicolon away, and we get the error. Not this one thing that messed me up as a learning programmer was whenever you miss a colon, the error is not reported on the line that's missing it, but rather the line afterwards. Messes me up. Because I think, oh, well, the error is here. It's expecting a semicolon. Oh, well, it has one. Why am I getting an error here? In reality, our error is up here. And so it can actually be pretty far away from where you are. You get that IntelliSense and the error message. So let's try to build, see what we get. Probably going to get the exact same error as we got before, which is the C2143 error, similar to the one that we had with the lack of this the right hand, the double quote over here. Okay. Let's add that back. Semicolon. Go down to finally, let's try something that surprisingly works. If we don't return 0, we can build this and it will work. And we can see that it automatically closed the console. Exit with code what? Where's the code? 0. So it automatically gave us code 0 when it returned. Okay, hit enter. Let's close this. Okay, so let's bring that back because return codes are important for other programs, not this one. All right, that completes the drills. No, not quite. We need to think of at least 5 more errors you might have made in typing your program. All right. So let's add a space between our colons. Will that work? It will. That's surprising. So it doesn't care about white space outside of the colons. What about in the middle? Yes, it will break in the middle. Right. So let's say we're being smart and the parentheses, oh, it's empty. We don't need it. Let's try that. Let's get rid of it. Well, everything's red and broken and it doesn't build. Well, it's syntax error, expecting things that aren't here. I guess it's expecting main to be an int. Alright. Okay, let's add that back. Nice and working. This is misspell import to import. Or get. Grab. Install. None of those are the import keyword. Import std. Let's try instead of IO std IO stream. Does this work? No. No. Std. Okay. Trying to figure what else we can break. Honestly, that's anything. Well, let's give a random semicolon. Hey, random semicolon doesn't break anything. I believe this is called a null statement because there's nothing. Just it's an empty statement. All right, how many empty statements can we do? A whole bunch, I imagine. Yeah, we can. All right, we can do that. So that works. Can we do that up here? Can we put a statement in a... Nope. Can we do this null statement outside of a function? Yep. Okay. That's interesting. It makes sense that if we can do it in a function, we can also do it outside of a function. Okay. Instead of a semicolon, stuff like that. Comment doesn't work. This one's a good one. So potential fixes. Nice. It doesn't replace it, it just adds it. Oh, autocomplete base version, super great, totally works. I jest. It's very useful and I very like it. Okay, I'm gonna stop it there. I think we've gone far enough. We hit review. And so I'll work on these review problems and then make a video on these. Probably write up a little thing that I can share with you guys as well. I can speak in a more script-like pattern, and we can punch through all these review questions at a later time. Thank you for watching, and stay tuned for the next video in this Let's Study series on programming principles in practice using C++, third edition, by Bjarne Stroustrup. Now, a little sneak peek on what we might be doing. You saw the videos on the channel most likely, or you haven't. I've also studied C, and so I've gotten mostly through this entire book with C, and I use C more than I use C++. I'm more familiar with C, and so I'll be continuing the series of the Let's Study series. I sort of don't have a Let's Study series of the C programming book, so I'll probably be starting. I will be starting from the beginning, just the way I'm working with PPP. And so that's an alternative series that will be in parallel with this one. Sort of they go hand in hand together. But in the future, some interesting topics. I've read a bit of this. So when I was in college, my minor was in physics. So I was a major in computer science from Westminster College, and I actually completed my major there. My bachelor's degree and my minor in physics. My focus was computational physics. And And my thesis of sorts, undergrad capstone, was a three-dimensional calculator program, which I will show in another video. But this is what we're working towards. Thick, dense, highly technical knowledge. Now, I've already worked through some of this book. Not a whole lot, but of course, I'll bring you guys along on this journey of learning computational physics. We're probably going to have to learn some physics, and very much we're certainly going to have to learn some mathematics to get towards this goal. Now, something we don't need to learn physics for, but we do need to learn mathematics for as well, is 3D game programming with DirectX 12. So, with the DirectX 12 API, we'll be able to, instead of programming our programs for the CPU, we're going to be programming our programs for the GPU, which brings in a whole new realm of things to consider with parallel computation. So we're going to be writing code, which instead of running line by line, only one place at one time, we're going to be writing code that will be running in several places all at once to converge on one similar goal, such as rendering a single image of many parts. And so we're going to go from a single-threaded CPU to a multi-threaded system of a GPU. Now, I've worked through this, got a few hundred pages, and I have a couple working programs with DirectX 12, and I'd love to share them with you, and I will. So we're going to get to this in the future as well. So, goals into the future. And next steps, if I can find the book quickly, I want to show it on screen. Oh no, where did we go? Yellow. Ah! I'm an organized person. Basic mathematics. So, this book, which I take with me almost every day to work, or have been for a while now, I have only gotten through about yay much of the whole book. And we're gotten into sort of a little bit, but it's a nice, this book is a beautiful refresher for, well, the adult who may not know very much math, such as myself. I know an embarrassingly low amount of math, especially for someone who studied physics. I have an embarrassingly low grasp or low intelligence with math, but certainly someone who can learn. So we're going to be learning this together as well. This book will be a Let's Study series as well. I'll most likely be making a video about this sooner than PPP, but we'll be working on all 3 of these books in series. Well, thank you for watching. That's a sneak peek about what's the future of this channel and videos I'll be producing, as well as I'll be producing some videos of fun side projects and whatnot and things I find interesting as well. So stay tuned. Thank you for watching. Please like, comment, subscribe. Please, if you have any questions, please put them in the comments and I'll try to address them the best I can. We're learning this together. I apologize in advance for the errors, which will probably be numerous in these videos, as they are made in a semi-live format. Okay, thank you and good night.